Okay. So I hope your friends who are not here, they are okay. And bukan saja-saja ponteng. I hope that's the case. Okay, so let's continue. So we talked about, yesterday we talked about chapter 20 punya last part. We talked about self-induction, right? Oops. Hello. Hello, baru start kelas kot. Don't do this to me. Sekejap barang. Okay, man. So we talked about self-induction. Self-induction. So the word induction, right? It means to induce. So here it says self-induced. So from self-induction, we will get self-induced EMF, whereby the change to induce the EMF comes from the system itself. And the EMF is proportional, the EMF equation is equal to L change in I over the change in T minus. Always, when we talk about induced EMF, we always have the minus sign because it's always trying to oppose any changes. Always have a minus sign. I'm recording, right? Yep. Always have a minus sign. And for self-induced EMF, we have a new constant called L, which is inductance. This is called inductance. And we talked about this in length yesterday, where inductance L is equal to N squared mu naught A over L. A is area, L is the length of the solenoid or the inductor, N is the number of coils times, it's a square. And mu naught depends on the type of material that you use. Mu naught is referring to when the material is air or free space. We will be using mu naught, not other materials. And then from this equation, we got to know that the inductance is dependent on the geometry of the inductor. So the geometry of the inductor is influenced by the area and by the number of coils and by the length of the solenoid or the inductor, length of inductor, and what else? The material that it uses to wrap the wire around. So the material of the conductor lah, basically material of conductor, which is the mu naught, which is free space. So area is A, number of coils is N, length of inductor is L, and then we have the mu naught. So here we saw from this equation, if we increase the area, then we will get an increase in L. If we increase the number of coils, we will get an increase in L. If we increase the length of the inductor, we will get a decrease in L. Okay, and the material of the conductor is mu naught. If you change it to other conductors such as iron or copper, you will get a better performance inductor. So that was from this equation. So this is the first equation. Your second equation. Do we have other equations? And then we talked about the direction of your induced EMF. So let me tidy this up. Good job. Self-induction. Group this together. Ooh, good job. Make it smaller. Ooh, that looks bad. Okay, so now we want to know how do we determine the direction, right? So look at this equation, the EMF equation. This is our equation. This is our second equation. So the first equation says that if I have a change in the current over time, then only I will get induced EMF. If I have a change in current within the system itself. So the change in current how do I say this? Influences the magnetic field, and the magnetic field influences the magnetic flux. And when you have a change in the magnetic flux, you will get induced EMF. But for self-inductance, you just have to remember that you always have to have a change in the current in the system itself. So let's draw. Okay, let's draw your inductor, because my drawing is always ugly. So this is your inductor, it's not mine. So we have a battery. Usually they don't label the battery because they want to use an AC battery, which we learned sikit je introduction yesterday. So typically they will use an AC battery over here. So tapi diorang tak nak serabutkan korang with chapter 21 in chapter 20. So they just say, okay, let's just say I is increasing or I is decreasing. So let's go for the first situation where I is increasing. When your I is increasing, you have a change in I over time. And this is proportional to your, what proportion is that? It is proportional to your EMF. Okay, so when my circuit is increasing in I, my current is increasing, what happens? So let's figure out the chronology. After I is increasing, obviously we start with the sad phase. Why? Because it always wants to oppose. It always wants to oppose. This is why the negative sign is there. It always wants to oppose. So when this guy is increasing, the inductor said, hey, stop. I don't want you to increase. I want you to go back to how you were before, which is stable lah. Dia tak nak increasing. Dia nak jadi macam a stable value. So what should the inductor do? It will try to push the I. It will try to push the I. This is your induced I. Okay, so we have your I flowing through here. So I can actually label my induced EMF to be this way. So this is the positive, this is the negative. This is my induced EMF. Typically, because you don't have color waktu exam, you would label this as dash. Yeah? So the battery that is induced or the EMF that is induced, you label it as a dash. So this is your positive and this is your negative. Your current flows from the positive, goes back into the negative. Okay, let's compare it to the battery that we started with, I increasing from this direction. So the battery was, the battery was like this before. Okay. All right, so what happens when I decreases? Kenapa saya terbalikkan? Let's start with the same setup. And then I have my inductor, which is very ugly. And my I is now decreasing. The I punya direction is the same. The battery is the same. The whole thing is the same, except that I changed the battery to have current that is decreasing now. So my I is decreasing. I have a change in I over the change in time. So I will get an induced EMF, right? Okay, so now it is decreasing. So what happens? I start with a sad phase. What should I do? I don't want this guy to decrease, so I want it to increase. So if I want this guy to increase, I will want to follow in the same direction so that when we combine, the value will increase. So I want to flow in the same direction as the I in the system. So if I'm flowing this way, I can say that my positive, I can say that my positive is over here. I should label it with a dash. And this is my negative, positive. Sebenarnya kalau label the dash je without putting in the positive and the negative pun dah understood it's a positive and negative. But I'm just labeling it here for you to be clear. Okay, so terbalik So I increasing, it was like this. Now decreasing, it was, the induced EMF is different now. The induced current is also in the opposite direction. I induced. Okay, so that is self-induction. Now let's talk about mutual inductance. So let's make this place for mutual inductance. Do I have space? Okay, so mutual inductance is pretty easy. It basically says I have two friends. Oh, what was that? So one friend is connected to an AC source, which means that the I is changing over time, which means that I will get induced EMF, right? I will have an induced EMF, and from the induced EMF, I will have, what do you call this? A magnetic flux. Let me label it with a different color. So this magnetic flux from the primary coil. So the first guy is called primary coil, the second guy is called the secondary. So the magnetic flux coming from the primary coil goes into the secondary. So this guy is primary. This guy is, okay. So basically I'm saying the primary magnetic flux is equal to the secondary magnetic flux. So if I were to label this, change in magnetic flux for the primary is equal to the change in magnetic flux of the secondary. So how do I change the voltage between them? The voltage between them is different by the number of turns, NP versus NS. Okay, they are not equal. Only the magnetic flux is equal. So NS, what do you call it? Magnetic flux over time. Okay, so you will get your voltage for the primary and the voltage for the secondary. And then we talked about the ratio and we derived it. I don't want to derive it again. So it was EMF is proportional primary over secondary or secondary over primary, doesn't matter, it's a ratio. Primary is proportional to, what was it, N, NP and S, but it is not proportional, it is inversely proportional to the I. Okay, so these are the equations that you need to remember for your exam. Okay, so I hope that was clear. That was your recap for yesterday's class. We covered a lot. So, okay, this one is done. Save. Good job. Okay, so let's continue with AC. So what have we talked about for AC current? Oh, sorry, saya tak share lagi. Stop sharing. Any questions so far? No questions? Semua cemerlang hari ni. So share. Okay. Asking question does not mean you're not cemerlang. So hari ni tak ada orang tak ada soalan. Okay. So I assume everyone understood what we learned yesterday. So draw. I'm sharing. I'm recording. Okay. So we talked about alternating current is a type of a power supply that is different than a direct current, a battery that we typically talk about in chapter 18 and in chapter 18 lah, cakap pasal DC, right? So here, alternating current can change polarity. So that was the first thing that we talked about. It can change polarity and it can change value. It can be increasing, decreasing, and it can flip sides. Meaning to say, if this guy is positive and negative and I want to flip it, I can. So I can make it positive here, negative here. So this is the advantage of using an alternating current. Okay, so how does it look like in terms of a graph? Okay, so this is how it looks like. It is sinusoidal in nature. It is sinusoidal in nature. It follows a sine function. Sine function yang math tu lah. Okay, sinusoidal, which means that it always needs to start from a zero and it reaches a maximum at a certain angle. In this case, it is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. So one complete cycle is 2 pi. Half a cycle is pi. A quarter of your cycle is pi over 4. Shouldn't say 1 over 4. It's pi over 4. Wait, kejap. Quarter. Why did I say quarter? Bukan. Pi over 2, sorry. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, betul. Okay, so at pi over 2, when my sine omega t is at pi over 2 or sine theta, okay, boleh je sine omega t or sine theta is the value of theta is pi over 2. Theta is pi over 2. Using your calculator in radians mode, when we have omega or when we have radians or when we have pi's, we always use in radians mode. Okay, so using your calculator in radians mode, you will find out that sine pi over 2 gives you a 1. Sine pi over 2 gives you a 1. So sine pi over 2 gives you a 1. Sine pi gives you a 0. Sine 2 pi gives you a 0. Sine 3 pi over 2 gives you a minus 1. So depending on what your value here is, your MBA omega changes. Okay, your MBA omega changes. What is MBA omega? MBA omega is your induced EMF for a generator. MBA omega is EMF for AC generator. So how does it look like? Looks like the rotating coil dalam magnetic field tu. So if you see this diagram, please know that this guy is an AC generator. Okay, memang gambar ni the typical diagram for an AC generator. You look at this, okay, there is a magnetic field, there is a coil, it's rotating. Okay, it's an AC generator. What equation should I use? I should use the EMF equals to NBA omega. NBA omega. However, this equation is not complete. So EMF is equal to MBA omega sine omega t. When can we use this equation? When they ask you voltage maximum or induced induced EMF at the maximum induced EMF is MBA omega, because at the maximum sine is equal to 1. So it's MBA omega je lah. If it's not at the maximum, then you need to use this equation, okay, because sine changes. Okay, sine can become 0, sine can become -1, again 0, and other values as well. Okay, so I'm going to repeat myself. If you see an AC generator diagram, please use EMF equals to MBA omega sine omega t. If they ask you the maximum induced EMF, your sine will be equal to 1. Your sine function will be equal to 1 at the EMF maximum. So your equation just becomes NBA omega. What is omega? It's your angular frequency or your angular speed. It's the same thing, okay, or speed. So omega is 2 pi f or 2 pi over t. If they give you frequency, use frequency. If they give you period, use period. Or you can just convert period to frequency. Sama je lah. F equals to 1 over t. Okay. And then if they give you theta, which is just the value of the angle in radians, then just use theta. You don't have to use omega t. Okay, so this is how you use the equation. Hopefully we have exercises later. Okay, any questions about this slide? Is everyone okay? Okay ke? Okay. Sekejap korang. Okay, so we talked about induced EMF. It follows this function. What is E naught?
Yeah,
What is E naught? E naught is your maximum EMF. Okay, what is your maximum EMF? NBA omega. Okay, so that's your E naught. So you have your induced current. When you have induced EMF, you also have induced current, which is I naught. So current also follows the same sine function. The only thing that does not follow is the resistor. Okay, we talked about this as well yesterday. So sama je, graph dia sama. Okay, so components. Oh, we don't want to talk about this one. Okay, kita kita continue with our example. So an AC generator consisting of 500 turns. So your N is equal to 500 turns, 50 times 150 centimeters squared. So that's your area. 50 divided by 100 times 150 divided by 100. You get this in meters squared. It rotates at a rate. So it rotates at the rate of 100 RPM. So rotate at a rate. Rotate, and it's talking about rate. When we have the word rate, it's always over time. So rotation over time is the rate of rotation. So what is rotation? When we are talking in radians, we are talking about 2 pi over time, or just radians over time. 2 pi ni complete cycle. So if they give me revolutions per minute, RPM, so RPM is revolutions per minute. You need to convert this to radians per second. So rev over minute times with, I want to get rid of revolution. One revolution is equal to 2 pi. I want to get rid of revolution, so revolution should be at the bottom. 2 pi should be at the top. I want to get rid of minute. I want to convert to seconds, so minute should be on top. And this is equal to 1 minute equals to 60 seconds. So I will get something in radians per second. So what was it? 100 and 30. 100. Okay, 100 revolutions. So 100 times 2 pi. Okay, 100 times 2 pi divided by 60. So you will get 10.47 radians per second. This is the SI unit for angular frequency. Okay, and you have to change it to this value to use it inside this equation. Okay, so now kita dah cari omega. This is our omega actually. Okay, calculate the maximum EMF generated. So maximum EMF, I told you before, EMF equation is MBA omega sine omega t, but if it is at the maximum, the sine becomes 1. So you are left with NBA omega. So N is 500, B is 1.5, sorry, I missed this, 1.5, and then we have the area, 50 times 150 divided by, or times by 10 to the minus 4, because you have 200s here. And then you times it with omega that we found over here. So this should be equal to 10.47. And you multiply everything, you will get something in volts. Do not forget units when you answer your question. Okay, so now it's asking you plot the instantaneous EMF versus time graph. What does it mean when we say instantaneous? So instantaneous is always with respect to time. Dia tak cakap pasal average. It's not talking about RMS. It's talking about, hey, what is the exact value at the exact time? Exact value at exact time. So here, basically dia nak cakap, okay, dekat, how do I plot this? Sekejap. Okay, so 2 pi, 4 pi, 6 pi. One cycle is 2 pi, 2 cycles 4 pi, 3 cycles 6 pi. Since I already know what is my maximum EMF, I know what is my peak value and also my minus peak value. So this is always E max, E max, E max. Okay, and then this is minus E max, minus E max, minus E max. Kalau saya laju sangat, bagi tahu if you want me to repeat any parts, please let me know. So it follows the sine function. We know what is the maximum EMF, and I told you at sine pi over 2, it is equal to 1, which will give us our E max. At sine 3 over 2, it is equal to 1, we will get our E max. So this is what is going on. Tapi ini dapat minus 1 lah, so minus E max. This is 3 over 2, 3 over 2 pi. This one is pi over 2. This one is tak tahu, 5 over 2. Oh yeah, 5 over 2. And so on. Okay, so if they ask you to plot, just draw a sine graph. The first thing I would do is draw a sine graph. Okay, label 2 pi for 1 cycle, 4 pi for 2 cycles, 6 pi for 3 cycles. If you want to stop at 2 cycles, it's fine. Asalkan lebih dari 1. Okay, so let's start from the beginning. So if I were a student, how would I answer this, right? First of all, I wouldn't care what the value is. I would just want to plot my sine function. Just to plot instantaneous EMF versus time graph. I know that this is an AC EMF. So it always follows a sine. So I just plot my sine. I don't care what the value is first. My sine is very ugly. Okay, so this is versus time. Label your graph properly. Seconds. And then this guy is EMF, which is in volts. Boleh lah tu. And then I label this as 2 pi and 4 pi. Okay, must be more than 1 cycle. Kalau tak tahu korang faham ke tak, what is the sine function. And then from my, I know that I need to have a maximum EMF. So I calculate from E equals to NBA omega. So I got the value from here, which is 5.89 times 10 to the 3. So I label this point as 5.89 times 10 to the 3. And if this is my maximum, my minimum would be a negative of that times 10 to the 3. Sama value, negative. Positive value, negative value. And the middle part should always be 0. Okay? So if you want to be fancy, you can plot this as pi, put here 3 pi, or you want to be more fancy, tambah lagi the values in between. Okay? So that is how I would do it. Draw your sine first, know what is your maximum value, what is your minimum value, always the negative sign of the maximum, and then label the rest. Okay, moving on. An electric generator has N equals to 150. Cross-sectional area is 0.02. Generator produces a peak voltage. So peak voltage, what does it mean by peak voltage? So when I have a, what do you call this? Bukit. So the peak of my bukit, of my mountain, hill, Bukit Hill kan? Okay. So the peak of my hill, so saya nak sebut peak of my mountain is always the maximum EMF. Oh, benda mountain tiba-tiba kan? So it's basically this guy lah. So when it says peak voltage, it's talking about over here. So this is your E naught or your E max. Okay, so your E max, dia dah bagi value siap-siap. E max is 24. You know the equation for E max. It is equal to NBA omega. You have N, you have A, you have the frequency, which means that you can calculate for omega. So omega is 2 pi F. So 2 pi, 12. This gives me 48 pi. Okay, so you have your omega. So now you can solve for B. Calculate the magnetic field of the generator. Okay, saya tak ikut sequence sangat, sorry. So basically what you need to know is what is the peak voltage? It is basically E max. What is the equation for E max? NBA omega. What is the equation for omega? 2 pi F. Okay. All right, so that is your first subtopic done. We have another 45 minutes. No, kita baru setengah jam. Okay, let's take a 7-minute break. 7-minute break, which means that we should come back at 11:53 a.m. Okay. Any questions you can ask me now. If not, please take your break. Lepas ni saya nak suruh korang buat lah pula. Penat cakap. We have 38. Jangan lupa sign in attendance on Putra Blast. 3 minutes to go for your break. Sorry for the background screaming. Macam itulah. One minute to go. No questions? Pandainya semua orang sekarang ni. Tak ada soalan pun. Tahu semua. Okay. Okay, 1 minute to go. Sekejap, where's my pen? I got my pen. Okay, lepas ni saya nak suruh korang buat exercise. So please pay attention to the following subtopic which is very important for your exam. Dia kasi hint dah. Okay, so current from a battery flows steadily in one direction in a DC battery, for a DC battery. So dia punya graph, the current from a DC battery, the graph is just a straight line. It's not a sinusoidal because it's supposed to be stable at equilibrium, straight line. At equilibrium here means the value does not change lah. It does not mean zero. Straight line value always at equilibrium, meaning to say it does not change. Okay, so straight line value always at equilibrium. So this is for a DC battery, the current coming from a DC battery. So this is if you have a an AC battery. So this is your AC's current, AC battery. You have your AC current. Okay, so your AC current follows a sinusoidal function. Okay, so we know this already. So I just wanted to show you that DC, dia punya graph is just a straight line. Okay, so the voltage supply varies sinusoidally as V equals to V naught sine omega t, or omega ni we can replace it with 2 pi f, or 2 pi over period times t. We've seen this equation before. It's the same equation as EMF equals to E naught sine omega t. Okay, so it's the same equation, only that is changing the EMF to V. Kenapa dia tukar? Sebab this is not a generator. We're not talking about a generator now. This was the equation for a generator, whereby E naught is equal to NBA omega. This one is in general. We're not talking about a generator. We're talking about AC in general. AC circuit in general. It's not a generator. So this is for a generator. This is talking about AC in general. So V for an AC circuit is V naught sine omega t, or V naught sine 2 pi f t. I is equal to I naught sine omega t, or I sine 2 pi f times t. And again, just draw your sine function, label one cycle as 2 pi, two cycles as 4 pi. Okay, this is your Vmax. Sama, V naught is your Vmax. This is your minus Vmax. It's the same thing. V naught is Vmax. Okay, sama juga for I. This is your Imax. And then this is your minus Imax. Same thing, one cycle is 2 pi, two cycles 4 pi. If you want to be fancy, you can label this value as well. Pi, 3 pi, pi over 2, etc. Okay. So now I'm introducing to you root mean square. Root mean square. Kita dah pernah nampak root mean square before in chapter 15. We talked about root mean square VRMS rasanya. VRMS for gas. But now we're not talking about gas, we're talking about electricity for AC. So AC current, AC voltage, selain daripada having a function, RMS is always a common term for AC. RMS is a common term when we are talking about AC. So what is RMS? It is the value of the max, I max, over the square root of 2, or 0.707 I naught, or I max. This is I RMS. Sama juga VRMS, Vmax over square root of 2, or V naught over square root of 2, or you can write it as this guy, 0.707 V naught. The decimal points will slightly vary if you use square root of 2 versus 0.707, tapi tak apa. Asalkan you know what RMS is, you can use either equation. Jawapan yang berbeza sikit tak apa. Oh my god, we have the pengacau here. What do you want? Yes?
It's green.
Why is it green?
Green.
Oh,
Green.
okay. Oh, it's clean. Okay, nah. Nah, take this, and can you go outside, please? Okay, bye. Close the door. Close the door. Okay.
Doctor,
Yep.
which one is the IMAX? Is it the I not?
Yes, I naught is Imax.
Same with the V not. V not means Vmax.
Yes, Vmax.
Okay, thank you, Doctor.
Okay, so V naught is equal to Vmax. I naught is equal to Imax. It's the same thing, eh? So when you have your equation V equals to V naught sine omega t, it is the same as Vmax sine omega t. V. Okay, sama. It's just a different term punya nama je lah, basically. It's the same thing. So if you have this graph, what is your V naught? This is your V naught. What is your Vmax? It's the same thing. Okay. And then this guy is your I naught or Imax. Sama. Okay. So please be aware that I naught and V naught is, the naught refers to max. Okay. So that was root mean square. Basically, your maximum value over square root of 2, or 0.707 times your maximum value. So if you want to find out what is, you have a VRMS and you want to find out what is the IRMS, so you can use the Ohm's law. If you use RMS, you will get in an RMS current. I'm going to repeat myself. If you use VRMS in the Ohm's law, you will get IRMS. If you use V naught in the Ohm's law, you will get I naught. Okay, so you can use regular V, you will get regular I in the Ohm's law. So the Ohm's law can be used for all of these different V's, but it depends on what type of V you are using. So if you are using RMS, you will get IRMS. If you are using IRMS, you will get VRMS. The R is not affected by RMS. The R is always not affected sebenarnya. R ni tak ada sign function. R ni tak ada root mean square. So resistor value is always just resistor value lah. Dia tak ada perbezaan kat mana-mana. Okay. So if you use VRMS or IRMS, you will get something in RMS value as well. So if, let's say I ask you, okay, the VRMS is, let's make up a question. The VRMS is 5 volts. The R, the resistor has a value of 15 ohms. Find out find the maximum I. So it's asking the maximum I. It's not asking about IRMS. So how do you use the Ohm's law to find the maximum I? You can. So first 5 equals to VRMS equals to IRMS R. So you want to find out what is your IRMS first. Your R is 15. So your IRMS is equal to 5 over 15 or 1 over 3 or 0.33333 ampere. And then you convert it to your regular I or your I naught. IRMS is equal to I naught over square root of 2. So you plug in IRMS value, which you got over here, into this equation. You can solve for your I naught. Okay. So again, when you use your Ohm's law, if you're using VRMS, you will get IRMS and so on. Okay, and then the rate, the direction of current has no effect on the behavior of the resistor. Okay, so the resistor is not affected by AC. Dia DC ke AC circuit ke, resistor tak ada effect. Dia kuat lah, cukup pula. Dia tak ada effect lah. Okay, so the current follows the Ohm's law. The rate at which electrical energy is dissipated by the circuit is given by I naught squared R. This is your regular equation. P equals to IV. Ini yang regular P, regular P, not root mean square. P equals to IV or P equals to V squared over R or P equals to I squared R. This is the equation. So it's saying power is equal to I squared R, or you can say this is I naught R. I naught R. Okay, when we talk about DC, which is not the root mean square or not the AC, we are always using I naught or just regular R. Faham tak? This is just the same as P equals to I squared R. Tu je lah. That's what I'm trying to say here. Ya Allah, panjang ni. Okay, so don't be confused with the I naught lah. What I'm trying to say. Okay, nanti kita akan tengok lagi. So when they are asking what is the power dissipated, it's asking what is the power dissipated by R. So you will have current flowing through R. So P equals to I squared R. So the value of R will be given, and then you need to find out what is the I. Do you use IRMS or do you use the maximum I? The answer is you use the I naught lah, because R ni, it's not affected by AC, so you use the regular I to find the P. Okay, kita bear with me first on this one. Nanti kita akan go back to this one. Okay, so average power. So average, you always, when we talk about average, we talk about the mean or 1 over 2. Selalunya lah, typically. So average power in this case is half of P naught. Half of P naught. Half of P naught. Okay. Ni graph P, okay. So this is the symbol for average power. 1 over 2 I naught squared R. This is average. Tadi kita tengok P equals to I naught squared R. This is the average, 1 over 2 I naught squared R, or IV, or V squared over R. 1 over 2, apa tadi? V naught squared over R. So, semua equation ni boleh pakai to find the average power in AC. Average perkataan average ni wajib untuk benda yang ada sign macam ni. Okay. Berbeza dengan the one that we saw earlier. This is just power. This is just regular power. This is average power. Okay. So average power can also be described in terms of RMS. Kita tahu I RMS is equal to I naught over square root 2. V RMS is equal to V naught square root 2. So if I wanted to convert this equation into RMS punya terms, so I just substitute I naught to be so I just move this over here. So I naught equals to square root 2 I RMS. And then my V naught is, bawa ke sini, V naught is equal to square root 2 V RMS. So square root 2, it just becomes 2. 2 with 2 cancels out. You get I RMS V RMS, or I RMS squared times R. This is a mouthful. So this still gives you the average power. Okay, so what do I want to highlight here? Let's go back. Equation ni dia agak confusing. Let's go back. Okay, so I talked about P. This is regular power. VI. V naught, I naught. Or I naught squared over R. I naught squared R, or V naught squared over R. And then we talked about average power. It must be 1 over 2 of regular power. 1 over 2 of regular power. 1 over 2 of regular power. So if I wanted to put in this guy over here, boleh. So I get this guy. I want to use this one, boleh. I still get this one, and I can use this one as well. So basically I can just expand it. V naught, I naught, 1 over 2. You know the drill lah. Just substitute your regular P into this equation. However, dia 1 over 2 regular P. But if I describe it in RMS, the 1 over 2 disappears. This is the difference. You have the 1 over 2 with the regular P, but when you use RMS, the 1 over 2 disappears. So it's just I RMS, V RMS, I squared RMS R, or V RMS squared over R for P average. Again, P average is 1 over 2 regular power. But if you are using RMS, the 1 over 2 disappears. Okay, so please be aware of that. Okay, so power ni tak payah. Okay, so in an AC circuit, kita akan cakap pasal AC circuit in series sahaja. Thank God, series sahaja. Okay, so in an AC circuit in series, the value of capacitor, the value of capacitor and inductor is different than in a DC. So this is the value. It's called capacitive reactance. It's a capacitor. It's a regular capacitor, but it is in an AC circuit. So the capacitance becomes 1 over 2 pi F times C. C is the value of capacitance. Okay, so dia ada perbezaan. It needs to have the omega C. 1 over omega C, or 1 over 2 pi F C. This is called capacitive reactance, where F is in hertz and C is in farad. Capacitive reactance will be in ohms. Now, in DC, kita cakap capacitor is in farad, right? In DC circuit, capacitors have the unit of farad, but in AC circuit, this guy has an ohms. It's weird, but it's a good weird because now we can combine. Okay, so it's in ohms, and the equation is Xc equals to 1 over omega C, where C is the value of the capacitor, or 1 over 2 pi f C. So that's your first one. So in an AC circuit, the inductor also does not behave normally like in a DC. So we have another equation. So this guy is XL, or it's called inductive reactance, omega L. Previously, we just talked about the value of inductors as L. Now we have to multiply omega with L. Tadi kita cakap pasal capacitor, the value is C. Now we have to multiply omega with C. Tapi untuk capacitor dia 1 over. Untuk inductor, is just equal to omega L, or 2 pi f L. It's called inductive reactance, where F is in Hertz and L is in Henry, which is the unit of L. XL will be in ohms again. So XL, omega L, 2 pi f L. So two equations now for AC. Where is the resistor? Tak cerita. Sekejap, So basically, you already know that resistors is not affected in an AC circuit. So resistor punya value is just R. So tak ada equation pelik-pelik, just use R as it is. Okay, so that's your so RLC series circuit. When you see this name, it simply means resistor, inductor, capacitor in series. Selalunya, bukan selalunya, memang dia akan cakap RLC untuk AC punya circuit. RLC series circuit refers to when it is in an AC circuit. Always. Untuk kita punya syllabus lah. Okay, RLC series circuit, always talking about AC circuit. When you talk about AC circuit, you know that we have capacitive reactance, inductive reactance, and also R. Okay, so this guy is in series. R is in series with L, is in series with C. So this is the voltage of R. So IR, dah bagi kita tak cakap lagi ni. So IR is your voltage, and then we have our voltage for the inductor, and then we have the voltage of your capacitor. In a series RLC circuit, the total opposition to the flow is called impedance. The total opposition to the flow is called impedance. So now, tadi kita cakap pasal inductive reactance, we talked about capacitive reactance, and also resistor, right? But when we combine these three together, the total of it is called impedance. It's not called reactance anymore. So XC, XL is called reactance. When you combine resistor with L, resistor with C, or resistor with L and C, it's called impedance. It basically means the total lah. But there will not be the name total in the word. So kena tahu, impedance ni maksudnya gabungan ataupun the total. Kalau tak ingat impedance ni maksudnya total, then you would think that it's a regular reactance. So you have to understand that impedance means total. Okay, it's not the same as reactance. Reactance untuk satu komponen, impedance untuk gabungan. Okay. Okay, so what happens when we have a combination, or we want to find out what the impedance is? So each component in the circuit will contribute to the amount of current through the circuit when impedance Z. We have a new term here, it's called Z, impedance. Reactance is X, impedance is Z. Okay, when impedance Z is at maximum, the current is minimum, okay, based on this equation. This looks like Ohm's law, but it's not. Ohm's law is V equals to IR. We don't have R anymore. We have impedance. So this becomes VIZ. VIZ. So if I wanted to know what is my I just rearrange this equation. So V over Z. If my Z is maximum, my I will become minimum. If my Z is minimum, my I will become maximum. Itu balik. sebab dia inversely proportional. Saya nak tanya soalan nanti, make sure you are focusing. So V equals to IR for regular circuit, V equals to IZ if you have capacitors, inductors and resistors in series in an AC circuit. Okay, so the total impedance is given by this equation, Z squared equals to R squared plus XL reactive inductance and also
What is it again?
and also capacitive reactance. I'm distracted.
Vivia?
Okay, can you go outside please and close the door?
Vivia?
Bye bye. Nanti mami cakap dengan Yusof. Go go go.
Vivia?
Okay, bye. Go away. Where was I? Okay, so this is the equation. If you don't want to use it in square, you can also tak apalah, nanti kita cakap pasal ni kemudian. Okay. So Z squared equals to R squared plus XL minus XC squared. Ohm's law says I not, oh so it's an Ohm's law walaupun Z. Betul. Tak apalah. Let's just say it's Ohm's law for now. So I naught V naught over Z or IRMS VRMS over Z. So boleh pakai. Again, if you use the Ohm's law, if you use RMS value, you will get RMS I. If you use voltage RMS, you will get IRMS. If you use IRMS, you will get voltage RMS. Okay, so since XL and XC is dependent on the frequency of the AC generated, the current in the circuit will also be frequency dependent. Okay, so what it is saying is that is XL is the omega L, right? Omega L is 2 pi F L. XC is 1 over omega C or 1 over 2 pi C. So it's saying that if we have inductors and also capacitors in an AC circuit, it will be dependent on the frequency because we have the term F in our equation. So if your circuit has 10 Hertz, it will be different compared to a circuit of 20 Hertz. Dia punya values akan berubah lah. Okay, it depends on the frequency. Okay. So this is the symbol for resistor. This is the symbol for capacitor. Capacitive reactance. This is the symbol for inductor. Inductive reactance. This is when you have a combination of resistor and capacitor. R squared plus XC squared, square root, impedance. It's called impedance sebab dia combination.
Why are you doing a spinner, Matt?
Okay, bye. And then we have a combination of resistor and inductor. So R squared plus XL squared, square root, is still called impedance. And we can have it when we have the three guys together, impedance. So I don't know if you're going to ask me this question, but I will ask myself. Can we have a combination of capacitor and inductor only? Does anyone know what the answer is? Boleh tak kita ada combination of capacitor dengan inductor sahaja? Kenapa saya tak lukis ni? Can we have this combination? Kalau tak boleh, kenapa? That's the question. So we have resistor, capacitor L. Ni sorang-sorang. Bila combine, dia ada R dengan C, R dengan L, R, L, C. But kenapa tak ada C dengan L? Anyone wants to try? Give me an answer. No one? It's related to the wires in your circuit. What is the inherent property of a wire? What does it have? No one? Dah lupa lah tu, belajar untuk exam je. Hari tu masuk exam kot soalan ni. Wire. Tak ingat. Okay, so I'm going to give you the answer. So wire, dia memang ada resistance, remember? So it depends on the material, depends on the length. We have resistance. So resistance always ada. Memang takkan tak ada. So R tak boleh kosong. Okay, ever. If R is 0, then something bad will happen. I'm just kidding. But R tak boleh 0 lah. Okay. So you won't have a C with L sahaja. You will always have R. So R with C, R with L, R, L, C. Okay. Okay, so let's go for the soalan. Sekejap. Do we have anything else to cover?
Why are you doing
Oh
this,
yeah, we.
Nathan?
Okay, bye. I need to teach first.
Why are you screaming, Nathan?
Yeah. Okay, so impedance is given by this equation. The impedance is minimum when XL is equal to XC. Why? Because this is our equation. When XL is equal to XC, this will become 0. So Z squared is just basically R squared. Z is just R, which is the minimum value. Remember, our circuit always have resistance. That's the bare minimum value of impedance. That's the bare minimum value. That's the minimum value for your AC circuit. So Z equals to R. This is called the minimum impedance lah. Assuming that your XL is equal to XC. So the impedance is minimum when XL equals to XC. At this condition, Z equals to R and the current is maximum. Because V equals to IZ. I is equal to V over Z. If Z is maximum, sorry, Z is minimum, you will get maximum I. Okay, so we want to talk about the condition for this to happen, the condition for XL equals to XC to happen. So it just equate 2 pi L with 1 over 2 pi FC. You will find out the F. So here F is called the resonance frequency of the circuit. Resonance frequency happens when XL equals to XC and Z equals to R. Okay, penting. Penting. Okay. I hope we are going. Okay, yay, exercise. Saya boleh berehat. So this is your first example. I want to have Shakira to do this. Ayuni, betul tak saya sebut tu? Ayuni and Danish. I need to remove this. Okay, so can we have Shakira, Ayuni and Danish to do this in 10 minutes? Boleh? Shakira, Ayuni, Danish, are you there?
Yes, Doctor.
Yes, Doctor. Okay, lemah tak apa. Sikit lagi nak habis dah kelas. Okay, Shakira, Ayuni and Danish, I'm going to give you 10 minutes. So 12:32. Let's discuss this one. Everyone else, please try yourself juga. Sekejap nak combine soalan. Nak suruh korang buat soalan banyak-banyak. So next one is this one. This one saya nak suruh siapa Fairuz. Saya nak suruh Fairuz buat yang ni. Is Fairuz there?
Yes, Doctor.
Okay, Fairuz buat yang ni Senang je. Okay, 10 minutes for you as well. And then this one. Sekejap nanti saya tunjuk balik soalan tu. Okay. Ada lagi tak? Oh, ada lagi satu. Okay, whoops, sorry. Memang tak cukup 4. Chicken secure. Okay, ni Fairuz. Nak suruh siapa Sofia. Sofia ada?
Ada.
Okay, Sofia A. And Sofara B. Sofara ada?
Ada,
Sofara? Okay, ada This one, Aina. Aina ada tak? Aina? Is Aina there? Sekejap korang. Aina tak ada? Is Ideal there? Dah saya tak pernah dengar suara Aina dengan Ideal ni. Oh, Ideal pernah.
Saya tak sempat screenshot.
Tak sempat screenshot. Nah, saya tunjuk balik. Kejap sorry. So this is
Okay,
the
dapat.
question. Oopsie. So saya buat 10. Kecil sangat pula dah. 12. Ya, nanti saya besarkan balik. I just need space. So Aina tak ada. Ideal ada tak Ideal? Ideal tak ada juga. So Sophia, Sofara, Aina tak ada. Who is next? Virus, Yani, Sophia and Sofara. Let me make this bigger. Oops, sorry. Sophia, Sofara. Siapa lagi lama tak panggil Divya rasanya. Is Divya there? Divya ada tak? So Divya is not there. Jaya, is Jaya there? Then macam baru panggil. Ada? Okay, Jaya exercise 21.2 Thanks Jaya.
Doktor here.
Okay, Divya buat ni This is the same question jap Divya buat 21.1, example 21.4. Oh, this is the same question. Okay, Divya tak payahlah. Nanti next time saya suruh Divya
Okay, doktor.
Sikit lagi. Please bear with me. Then we are done with this chapter. Tak boleh buang ni. So let's start 12. So bagi masa lebih sikit lah. 12:35. Okay, let's come back and discuss all the answers to this. How to do it.
Doktor. Doktor.
Yep.
Yang soalan awal-awal tu kan, dia ada figure dia ke?
Figure jap Oh, ada. Saya terbuang. Oh my god. Sekejap Source if the maximum find the frequency. Sekejap. Saya tengok sekejap soalan ni boleh jawab tak without the figure. Variation of voltage. The source is connected to R. The maximum voltage find the frequency. Oh, tak boleh. Okay, sekejap Lemak. My bad. So sorry.
Mommy.
Doktor ada ke?
Ada? Kenapa?
Doktor yang soalan satu tu kan, dia guna formula V sama dengan V naught sin omega T
Dia punya apa lagi sekali?
Yang soalan first to A tu kan, yang frekuensi tu kan. Dia guna formula V sama dengan V naught sin omega T.
Dia tanya pasal frekuensi. So frekuensi ni related to period. So what is the period of one cycle kat sini?
Tapi
Kat sini cycle ni kan? Okay. Dia complete one cycle dekat berapa saat?
yang T yang hujung tu doktor.
Yang ni? Bukan.
0.08.
Bukan. 0.08 tu dah 2 cycle. So sin function dia complete one cycle macam ni rupa dia. 1, so 1 and then kat sini 2. So kalau kita nak cakap pasal frequency related to period. Period is time to complete one cycle. Okay. So sekarang
Maknanya cycle dia, satu cycle dia 0.04. Jadi frekuensi dia 1 bahagi 0.04.
Yes.
Saya ingatkan guna equation yang baru belajar punya saya.
Ada juga yang equation yang kita baru belajar tapi untuk soalan lain lah. Okay, ni F je. Pasal F je. Okay.
Okay, faham.
Okay. Jangan macam mami kau.
No.
Shh, let me sing. Okay, so is everyone ready? Can we start discussing now? Do you need more time or are we okay?
I need more time.
Need more time. Okay, let's give 3 more minutes. 3 more minutes. Okay, Sophia, you can do it. So 8. Kenapa saya tak boleh lukis?
What is this?
Janganlah pasang kat mami punya tu. Go. Okay, saya nak duplicate slide. Oops.
What is one? Mommy, what is this one? What's the ball?
Okay, later. Next slide. Okay. Okay, is it time yet? 1 more minute. Ni siapa tadi? Oh, ni virus. Alright.
Don't read. Don't read.
Okay, so it's time. I hope Sophia berjaya. If not, while kita menjawab ni, Sophia boleh continue. So Shakira,
Tak jaya juga.
tak dapat? Dapat tak? Tak dapat? Okay, it's okay. Nanti kita discuss. Don't cry. Don't cry. Okay, so Shakira, can you explain how to do A, please? Shakira?
Ya.
Okay, macam mana?
Dia nak frekuensi. Jadi formula dia F sama dengan 1/T. Itu maksud dia nak time untuk complete satu cycle.
Okay.
Jadi kalau satu cycle tu dia bentuk dia macam sign tu. Sign yang kan bentuk sign
Satu
cycle tu. Yang atas bawah gitu. Macam tu. Lepas tu dia punya kat situ satu cycle tu 0.04.
Okay. So jawapan
Jadi satu dia sama dengan 25 Hz.
Hertz. Okay, betul? Good job. Okay, kalau saya tukar, Shakira, kalau saya tukar value ni kepada kepada 10 second, adakah frekuensi saya berubah?
Berubah?
Sebab?
Berubah.
Okay, berubah sebab?
Sebab nilai dia tak sama.
Okay, nilai dia tak sama, betul lah. Sebab bila saya tukar the time to complete one cycle, I am changing the frequency lah, which is nilai dia berubah lah, betul lah cakap Shakira. Okay, so I hope everyone understands that what does one cycle mean? What does T mean in one cycle? So T always one cycle sahaja, Kalau dia kasih 3 cycle pun, the T is always just about 1 cycle. The T is always just about the 1 cycle. And T is always in seconds. So if your graph is in radians, you cannot use this equation. If your graph is in radians, you cannot use this equation sebab T is in seconds. Okay, itu cerita lain lah. Okay. So okay, good Shakira. So B is Ayuni. The RMS current through the resistor. Macam mana nak cari?
Yes, betul.
Okay.
Saya guna equation VRMS equal to IRMSR. So jadikan IRMS tu subject. So sebab dia nak RMS current ni. So jadi VRMS over R.
Okay.
Lepas tu cari VRMS.
Okay, macam mana nak cari VRMS?
V naught over square root 2.
Okay.
So V naught dia dah bagi 240.
Okay, kat sini. Okay, betul. 240.
So 240 divide by square root 2 equals to 169.71.
Berapa lagi sekali? 69.
169.71.
Okay.
Lepas tu
ni.
masukkan. Jadi 169.71 divide by 4.5 times 10 power of 3.
Okay. Times 10 to the power of 3. Okay. So your answer is
0.038.
0.03A. Okay. Saya tak tahu jawapan dia, so I hope dari segi jalan kira dah betul. So hopefully the answer is correct. So let's go to C. Thank you Ayuni. C is Danish. Oh my god. Sorry guys. Harap tak ada yang pekak.
For the C, we using the equation P equal to I square times R.
I squared times R. Okay.
And then we 0.038 ampere times 4.4500 ohm.
4,500 ohm. Okay.
And then we get 6.4 watt.
6.41.
It's spider.
The third 6.
Mommy, it's spider. Spider.
Okay. Sorry. 6 point berapa tadi?
6.4 watt.
Watt. Oh. Okay, 6.4 watt. Okay, Danish nak tanya.
Yes,
Kita nak cakap pasal average power. So kat sini awak kasih saya regular power. Power yang biasa saja. Macam mana saya nak tukar ni jadi average power? Okay, ni average Jangan kacau. Okay. So kat sini tadi Ayuni dia cakap this value is IRMS. Bukan I. So macam mana equation awak kena tukar untuk dapatkan P average? Okay, saya kasih hint saya list down equations yang kita belajar. So P equals to I squared R, which is regular power. P average rupa dia macam tu, 1/2 P, or P equals to I RMS V RMS. Okay. Or I RMS squared over times R, or V RMS squared over R. So which equation did you use to find the average power? Jawapan awak betul, tapi equation ni salah. So which equation should you use?
1/2.
1/2. 1/2 P. Awak nak pakai yang ni? Okay, tapi
Yes.
0.038 awak ni IRMS. Yang ni, value ni IRMS. So macam mana awak nak dapatkan I? Boleh je kita nak pakai equation ni. Let's do it. Okay, kita buat So P average equals to 1 over 2. Janish nak pakai I. So how should I convert I RMS to I? Macam mana saya nak tukarkan jadi I?
I not over 2.
I not over 2. So tu Umar. Janish cakap bersama tak jawapan dengan Umar? Janish tak tahu ke?
Yes, betul. Over 2.
Over 2? Betul ke?
Ada tinggal tu Dennis.
Over? Sikit lagi nak betul.
Over punca kuasa 2.
Punca kuasa 2. Yes, thank you. Okay, so over punca kuasa 2. So I naught equals to, I RMS equals to I naught punca kuasa 2, bukan over 2 punca kuasa 2. So kalau saya ada I RMS, saya nak I naught. So saya kena darabkan I RMS dengan square root of 2. So 0.038 darab dengan square root 2. Tadi Danish nak pakai 1 over 2 regular P. P dia I squared R. So yang ni kita squarekan. And then R is 4,500. Okay, let's see jawapan dia akan sama tak. Okay, again. Ni equation P average equals to 1 over 2 P, where P is equal to I naught squared R. This is the equation that we are using. Sebab Danish tak nak pakai RMS. Dia nak pakai I naught juga. So kita buat. So 1 over 2 I naught squared R. So 1 over 2 0.038 times with square root 2. Sebab saya nak tukar RMS ni kepada I naught. Kita pakai equation ni. Squared. Lupa nak squared. Oh ada squared sini. Tak perasan. Darab dengan R. R kita 4,500 ohm. So the answer is, I don't know. Ada orang dah kira tak? Times square root 2 divided by 2 times 4,500. Betul tak saya dapat ni? Buat berapa korang? 120 ke?
6.49.
Oh, sedap. Saya salah tekan kalkulator lagi tu. Sekejap saya try lagi sekali. 0.038 darab square root of 2 darab square root kan, squared kan, divided by 2 times 4,500. Tak dapat juga. Okay lah, abaikan je lah saya punya skill calculator ni. So dapat berapa tadi Umar? 6 point?
Fakri.
Oh Fakri. Fakri dapat berapa?
6.49.
6.49. Orang lain dapat sama tak?
Sama. 6.498.
Buat. So kita boleh pakai cara Danish. Tapi dengan syarat kita tahu what is our I naught. Mana nak tahu I naught dapat daripada I RMS. Or you can just solve for I naught daripada awal lagi. Which is 240 divided by 4,500. Dan ni adalah V naught. This is R. You will get I naught. If you want to use that way. So banyak cara untuk jawab soalan ni. So in this one, jawapan dia sama sebab dia pakai I RMS squared times R, which gives us the P average juga. Okay, so that is C. Hopefully everyone understood that. Okay, moving on. Kalau ada soalan boleh tanya sekarang. Kalau tak ada, kita akan go forward with the next question. This one is Fairuz. Fairuz dah ready ke?
Dah doktor.
Okay. So what's the answer?
Kita guna equation capacitive reactance
Okay, so XC equals to?
equal to 1 over 2 pi frequency capacitance.
Okay. Equals
Kata kita susun, kita jadikan situ subjek dia.
1 over 2 pi FXC. Okay.
Tu masukkan nilai. Jawapan akhir dapat dengan
2 pi F is 110. This is your XC. So 35. Jawapan dia?
Okay, 4.13. Eksponen dengan apa tu? Negatif. Bukan. Kuasa 10, negatif 5.
Kuasa 10.
Kali 10 ni kuasa negatif 5.
Sekejap lagi sekali pada awal. Apa value depan dia?
Okay. 4.13.
Okay. Darab.
Okay. Darab 10, kuasa negatif 5.
Okay. Dia punya value?
Value dia Farad.
Alright. Okay. Okay, thank you, Fairuz. Next one. Sophia. Sophia dapat tak? Bukan. Betul lah ni Sophia. Jaya ni next one.
Tak dapat.
What do you have? What do you have? Tell me what do you have?
So mula-mula cuba so I try to find the XL, which I don't think works.
You try to
I know
find
XL.
XL. Okay, so how did you find the XL?
2 pi FL.
2 pi FL. Okay, 2 pi, your F is 100. This is your F. L is this guy, 60 millihenry. Right. Okay, that's your first step.
Yeah.
Okay, so what did you get for this one?
I just erase it. Let me erase it.
Apa?
I erased it because I thought it was wrong.
You thought it was wrong. Taklah betul lah. Okay.
37.670.
37.
Or 70 ohm.
Tak dengar lagi sekali.
37.70 ohm.
0.70 ohm. Okay. And then lagi?
And then I find the XC.
Okay.
1/2 pi FC.
Okay.
1/2 pi, the F is 60.0 hertz.
Why is the
And
F 60.0 hertz?
Wait, I counted. Wait, no, I'm looking at the wrong place. 100. I'm sorry.
100. Okay. So
100.
the same for
Yes.
everyone. Okay, but to C is
The C is the T.
the 30 micro. Don't forget the micro. This is your C. So 30 times 10 to the minus 6. So what's your XT?
I forgot the micro.
So kena ingat. Lupa-lupa.
$4.71 times 10 minus 3.
Times 10 to the minus 3. What's the unit?
Ohm.
Yes. Okay, what about the R? What's the value of R?
The R is 20. Right.
20. So what is the equation for impedance?
Impedance for in series is. Wait, what did I put? Z equals to square root of R squared plus X squared.
XC ke X squared?
X squared.
X squared. Saja. We have XL here.
Oh no, the X plus XL squared.
Are you sure it's plus? It's a minus squared.
Wait, let me check. It's minus.
So is it XL minus XC or XC minus XL?
XL minus XC.
XL squared minus XC squared. Like that. Okay, so yang ni tak ada square because dah square root kan. So plug in your value plus XL is 31.7 squared minus 4.7 times 10 to the minus 3 squared. Okay, asalkan jalan kira betul-betul lah tu. Saya rasa orang lain boleh kirakan kalkulator juga. So the final answer should be this guy. Tak tahulah betul ke tak. So Sophia dah faham dah ke how to use this?
Yes.
Yeah, so if you have all three together, you need to use the complete equation. Tak boleh r squared plus xc squared sahaja. Tak boleh So you have
Okay.
all the three things together. Okay, so Farah is for B. Calculate RMS. Okay. So Farah?
For B, we use equation IRMS equals to VRMS over Z.
Okay.
And then IRMS equals to 20 over 25.18.
Okay.
And then the answer is 0.79
ampere. Okay, that was easy because kita terus dapat yang ni kan. But the A is slightly difficult for Sophia. So sorry, Sophia, you got the hard one. Okay, thank you, Farah. Next one, last one. Last one, and then we are done. So Jaya, let's do this quickly. A series AC squared. Okay, how did you do it?
So Dr. FR equals to 1 over 2 pi, then bracket square root LC.
Sekejap lagi sekali, Jaya. Sorry, tak dengar. Okay, again.
FR equals to 1 over 2 pi.
F.
In bracket.
Oh, FR resonance frequency equals to 1 over
2 pi. In bracket square root LC.
Square root LC. Okay.
Then L need to be 60 times 10 to the power of -3. And then it's multiplied by 2.5 times 10 to the power of -6.
Oh, okay. So square root of 60 times 10 to the minus 3. Ada milli kat sini and then ada micro kat sini. So don't forget that. I'm not talking to Jai, I'm talking to everyone else. Don't forget that. Selalu ramai orang tertinggal. Okay, so this should give you the frequency, resonant frequency. So did you get the answer?
So in the square root, it will be 1.5 times 10 to the power of -7.
1.5 times 10 to the minus -7.
Yeah.
Okay. So with that, you got the 411. Did you get it?
I got 410.94, which is 411.
Okay, 410.94 hertz. So it's frequency, so it should be in hertz. So if you don't remember, thanks Jaya. So if you cannot remember this equation, just equate XL equals to XC. Okay, so remember the equation XL, you remember the equation to XC, equate them together, 2 pi, apa tadi? FL equals to 1 over 2 pi, what is it? 1 over 2 pi FC. Okay, so you have the F here, they are the same F. That's your subject. So equate them together to get this equation, or you can just memorize the equation. Okay, we are done with chapter 21. Congratulations, everyone. Okay, so have a great rest of the day. Have a good lunch if you're having lunch, and selamat berbuka later. Okay, so take care, everyone.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Kenapa Umar cakap ambulance is coming? Tak faham. Or is it?
Oh, just now Yusuf sounds like ambulance.
Oh.
Nino, Nino.
Maafkanlah dia. Dia memang mistake mampus. Okay, bye guys. Take care.
Thank you, Doctor.